Hi, this is Yan Liu reviewing my second out of 3 papers for the course COMPX529. The title of the paper is Understanding Uncertainty in Self-Adaptive Systems. The authors are Radu Kalinscu, Rafael Mirandola, Diego Perez Palacin, and Danny Wins. The paper was published on August 2020 at IEEE International Conference on Autonomic Computing and Self-Organizing Systems. The problem that the paper tries to solve is basically the same as the title, how to understand the uncertainty in self-adaptive systems. It is a key driver for self-adaptation to ensure that the system can achieve its goals and uncertainty. However, the concept of uncertainty in self-adaptive systems is still insufficiently understood. Although several taxonomies of uncertainty have been proposed, taxonomies alone cannot convey the SES research community's perception of uncertainty. There has been a common topic of debate among the members of the community. Some people argue that no human-made system can handle unanticipated phenomena, while others argue that dealing with such phenomena is exactly the key challenge of self-adaptation. So, clarifying such differences in opinion is crucial for the community. Unfortunately, uncertainty is a complex concept that is difficult to understand, let alone to manage. There are a number of researchers have proposed the initial taxonomies of uncertainty for self-adaptive systems. While this taxonomy focuses on uncertainty as a key driver for self-adaptation, the SES research community's perception of what constitutes uncertainty remains unclear. Also, the number of studies in this area has been increasing. Most of these studies assume that decision-making processes are executed by humans. However, in self-adaptive systems, the decisions are primarily made by software, so a more systematic understanding of SES uncertainty is required. The authors list a set of studies on the notion of uncertainty in self-adaptive systems. They provided a definition and a taxonomy for uncertainty in dynamically adaptive systems. There's also taxonomy modeling that comprises 3 key dimensions: location, level, and nature. Systematic literal review was done on uncertainty in self-adaptive systems, and the authors derived a systematic overview of uncertainty dimensions. Some discussed several sources of uncertainty affecting modern software systems and argued that uncertainty in software systems should be considered as the first-class concern throughout the whole system life cycle. Some studied this topic with an emphasis on different sources of uncertainty. The paper aims at shedding light on the perception of the SES community on the notion of uncertainty in self-adaptive systems. To this end, the authors conducted a survey about 1. The ability of systems to deal with an unanticipated change. 2. The uncertainty in SES models. And 3. The challenges of handling uncertainty for systems with strict requirements. The 51 survey participants are actively involved in research on self-adaptation in the broader community. Data are collected using a questionnaire. To obtain a representative sample, they give the questionnaires to the researchers attending the main SES conferences and complemented this with directly email sent to additional SES experts. They translate the overall goal to 3 research questions to be answered by the survey. First question is, what is the perception of the community on the ability of self-adaptive system to deal with the changes that were not anticipated. Second question is, what is the perception of the community on the representation of uncertainty in runtime models and the paradigms used for modeling? Third question is, what are the challenges for uncertainty in self-adaptive systems perceived by the community, in particular for systems with strict goals? Then they perform the following steps: planning the survey, conduct the survey, data analysis, and documentation. The result shows that the survey generated multiple insights. The majority of the participants consider that self-adaptive systems can be engineered to cope with unanticipated change. Uncertainty can be represented using parameters and the structure of runtime models. There are also proposed techniques to handle uncertainty, include software evolution, online modeling mechanisms, and learning techniques. The survey results suggest the need for a research agenda centered on assurance, proactive adaptation, integration with machine learning, and scalability. Emerging challenges include self-explaining ability and ethical aspects. Previous research has studied the notion of SES uncertainty based on existing research literature and on individual projects and experiences. While this paper complements these important efforts by presenting insights on the SES research community perception of the notion of uncertainty in self-adaptive systems. There's no evaluation related this survey to any actual systems. However, the authors assessed the possible threats to the validity of the study. They mainly focus on three aspects. Construct validity is tried to obtain the right measure and whether they defined the right scope in relation to the study goal. External validity is so that the findings can be generalized. They select participants at the mean value of the community and invited additional experts, increasing the confidence that the sample was representative. Reliability is mainly to ensure that their results are the same if their study would be conducted again. The data analysis and the coding are creative tasks that are to some extent subjective. To mitigate bias, two researchers performed the data analysis of each question on an interactive way, and then the results were cross-checked by the two other researchers. In addition, they made all the materials of the survey publicly available. The work was generated by gathering and analyzing response to a survey. The participants, of course, were researchers with experience in dealing with uncertainty in self-adaptive systems. However, the types, areas of their expertise of the SEAS system were not clarified in the paper. For example, is it a pure software system or a system to control workflow for certain industries? That's also very important to the result because different kinds of systems hold different uncertainties. They are facing very different actual problems. Also, the number of samples can be increased to prove a more accurate result. Third one is only human opinions considered to the conclusion. Although this is a topic of understanding, referencing some typical examples of SES systems may help to prove the conclusion.